This video is in response to a question about using the normal probability plot to assess normality, section 7.3 in the book. A lot of times when doing things that require the use of statistics, we want to determine whether or not we can use a normal distribution to make our analysis. And so one of the assumptions with the normal distribution is that our population is normally distributed. So one of the ways to do that is to create a normal probability plot. And that's fairly easy to do using StatCrunch. So here is a problem asking about a sample of O-rings and whether or not we can say that the population is normally distributed. So basically, with a normal probability plot, if the plot is approximately normal, then we say, approximately linear, then we say yes, we can assume that the population is normally distributed. So we're going to go ahead and open StatCrunch. And here's all the data from that table. And we'll go to Graph and use QQplot. I have no idea why they named it that. Our data is in var1. Now, a lot of times in the homework problems in the book, they actually show you a graph and want you to match it. And so if you want to match the graph, you always have to make sure you click normal quintiles on the y-axis. And we're also specifically looking for our correlation coefficient because that's going to help us determine how close our data is to the line that is created on the plot. So we make sure we also check that so that we can see the correlation coefficient, and then we hit compute, which is currently off the screen. So compute, and we get this line. So this is all the data, and you can see that pretty much none of it falls exactly on this line. You're going to learn more about these lines and correlation coefficient in Chapter 4, which doesn't happen till later in the semester. So for now, we're just looking for something that's close to this line, and so we look at this correlation coefficient. It's 0.977. So that's our number that they're asking about here. The correlation between the expected z-scores and the observed data is that correlation value. Now, if we're trying to figure out if it is linear enough, we want to click on this table of critical values, and it depends on the size of our sample. So how many data points do we have here? We have 4, 8, 12, 16. So that's our sample size. So our sample size n is 16. And so it says the critical value for a sample of size 16 is 0.941. So if our correlation coefficient is bigger than 0.941, then we say it is linear enough. If it's smaller, we say it is not linear enough. So because it is bigger than that, so basically if it was exactly 1, all of the points would be on the line. And so we want that correlation to be as close to 1 as possible. So if it's closer to 1 than the critical value, then we say it's linear enough. So that's how we decide that. And so your answer here for this problem would be yes, the correlation between the expected z-scores and observed data exceeds the critical value. So we can conclude that the data comes from a normal population. I hope this helps.